Hi, my name's Miss Megan and I'm a 5th grade science teacher. My student assistant, Miss Sediment here, is going to represent our class today. We are going to be showing you a great engaging product, Erosion Rocks, which is a hands-on opportunity for your students to experience weathering and erosion in real time. As the rain falls onto these erosion rocks, they begin to break apart and weather, allowing your students to see what actually happens. Beware of landslides and watch out for caves. Miss Sediment and I will demonstrate our experiment in real time. Good morning, class. Today we're going to do an experiment on erosion and weathering. But first, let's start off with some vocabulary so we know what we're talking about. Help me out by filling in your worksheet as we go over it with the board. Weathering, the process of rocks. What could it be the process of?
Process of breaking down.
Breaking down. That is exactly right. It is the process of breaking down rocks. How are some ways in real life that weathering occurs?
Well, it could happen by wind.
Wind.
Or it could happen by rain.
As rain falls on them, yes.
Yes, or ice.
Yes.
Ice could get in it and it could make it expand.
It could expand.
Or the plants.
How would plants weather rocks?
It could grow up through the cracks and make it expand also.
Make it expand as the roots grow through it. Very good, very good. Now, as the rock breaks, we have pieces of broken rock. What might we call those pieces of broken rock?
Sediment.
Sediments, that is correct. Sediments are pieces of broken rock. Now, do the pieces just stay there?
No.
They begin to move from one place to another, and what do we call that?
Erosion.
Erosion, and erosion is the what of sediments?
Movement.
The movement of rocks. Very good. Movement. Very good, very good. And as they move, they begin to be deposited in other places. We call this deposition. That deposition is the process of what? What is
dropping off?
Dropping off, exactly. Deposition is dropping off, or settling down and building up of sediment, so they drop off. Now, as weathering occurs, there is often a sudden downhill movement of these sediments. What might we call that?
Landslides.
Landslides. All that sediment coming down. Very good, very good. Landslides. And sometimes there's an underground space that's formed by the erosion and movement. What do we call these underground spaces?
A cave.
Caves. And they're formed by the weathering of sedimentary rocks as well. We have caves. Now, sedimentary rocks is a type of rock that is made from layers of sediment that have been, how do you think these rocks are formed?
They're compressed and cemented.
Cemented together. So as these sediments drop and deposit, they begin to become compressed and cemented together. Very good. Now, today in class, we are going to create a model. But what is a model?
It is something that represents the real thing.
Wonderful. So this is a model. It is going to represent the real thing, the model of erosion and weathering. All right, class. To do this experiment, we do have some equipment that we will need to do. Of course, each one of you will receive an erosion rock. Please don't touch it until you have been told what to do with it. You have a 12 by 12 piece of aluminum foil. Now, it's very sharp on the edges, so you're going to want to be careful handling it. Move slowly. We do have a drip tray that will be the base of our mountain. We have water and pipettes. The pipettes will represent the clouds in this experiment. And let's make our water, since it'll be the rain, blue. Give it some color. The darker the better. We have a teacher squirt bottle, which I will be using as I come around the classroom. And of course a baggie. I will tell you what the baggie represents at the very end of this experiment. All right, let's start by making our mountain. What should we call this mountain?
How about Sandy Mountain?
Sandy Mountain. I love it. So be careful handling your aluminum foil. And we're going to take a fist and place it in the center of the foil and begin to shape our mountain around our fist. Now our sandy mountain begins to form. You want to place her in the drip tray. And go ahead and smooth out the edges so that we have our mountain shaped just like that. Very good, very good. Now go ahead and take your special erosion rock and place it right on top of Sandy Mountain. Just like that. Very good. Let's begin by making some predictions. Our pipette is going to represent condensation in the clouds above the sky. And as the water drops onto our erosion rock, this is going to be rain or precipitation for millions of years. What do you think is going to happen as millions of years worth of rain begins to fall onto our sedimentary rock?
I think weathering will take place.
And what does weathering mean?
It is the breaking down of rocks.
The breaking down of rocks. Very good, very good. And it's going to break down into what? What do we call that?
Sediments.
Sediments, which is what?
Little tiny pieces of rock.
Very good, yeah. It'll break down into sediments, little tiny pieces of rock. Now, are those sediments just going to stay in one place?
No.
What's going to happen to them?
They will start to erode down the mountain.
Erode. Erosion will take place. And what does erosion mean?
It is the carrying of sediments down.
Very good. Down. It's just the carrying of sediments. Very good. The movement of sediments. Now, what's going to happen after these sediments have been moved?
They will deposit.
Deposit, deposition. Very good. And what does that mean, though?
It means they drop off.
They'll be dropped off. They'll be deposited down here at the base of Sandy Mountain. Very good. Very good. Now, what else might happen if, say, a lot of sediment goes downhill at one time?
It will create more land and begin a landslide.
A landslide. Very good. Oh, big chunks of sediment will fall down. What else might occur on our sedimentary rock?
There will begin to form caves.
We can make some observations and see if any caves form. Very good. Weathering and erosion is what creates caves. Wonderful, wonderful. And we call this a model. What is a model?
It is a representation of the real thing.
A representation. So we have Sandy Mountain, and it's representing a mountain that we might see out in the world, right? We're going to want to use the vocabulary as much as possible. Throughout the experiment, I will come around and rain for you. When that's happening, I want you to use your pipette to point to where the vocabulary word is happening and describe it to me. Remember, use the definitions.
Okay.
All right, you may begin the experiment. It's better if you hold the rain about 8 inches from your sedimentary rock. Wonderful. Let me be your rain for a minute. Okay. So as it's raining, can you point to me where weathering is occurring?
Yes. Right here.
And what does weathering mean?
It means the breaking down of rock.
Wonderful, wonderful. And is there any erosion?
Yes, the sediments are getting carried down around right here.
Wonderful, wonderful. Now, where do those sediments go?
They deposit at the end of the mountain.
And what does deposit mean?
It means to drop off.
To drop off. Wonderful. You're doing a great job. Go ahead and continue weathering your mountain as millions of years of rain falls onto it. Let's go ahead and stop right here. And let's draw a diagram that will represent this model we've just created. Let's create a diagram of Sandy Mountain, the model that we've just created. What should I draw first?
You should draw the mountain.
The mountain. Wonderful. So let's go ahead and do that. Draw our mountain. And what do we call this mountain?
Sandy Mountain.
Sandy Mountain. So we need to make sure that we label everything. We have Sandy Mountain. Wonderful. Wonderful. And let's go ahead and draw our sedimentary rock here on top. Go ahead and leave like a little bit down here because we know that some of the rock has been broken apart. What do we call that when the rock is broken apart?
Weathering.
Weathering. Wonderful, wonderful. Now, up at the top we had our pipette. And what did the pipette represent?
The clouds.
The clouds. Or let's use a science word. What's a science word for clouds?
Condensation.
Condensation. Wonderful. Condensation. And when condensation gets too heavy, what does it turn into?
Precipitation.
Precipitation, which is the rain that came out of our pipette. Now, did this happen in a real short time?
No, it was over millions of years.
Millions of years, yes. Weathering takes millions of years worth of rain. So let's make sure to add that to our diagram. Millions of years. Millions of years is precipitation. Now, as the precipitation hit our sedimentary rock, what began to occur?
It began to weather and erode.
To weather and erode. And from the weathering, what came out of our erosion rocks?
Sediments.
Sediments. Wonderful. And we call that weathering. Now, you said erosion. What does that mean?
It is the movement of sediments.
The movement. And which way did our sediments go?
Down.
Down. They went down. We have erosion. Now, out in the real world, this movement or erosion of water, what do we call that? All the water in one spot going down.
Deposition.
Not deposition yet. We have all the water coming down. What might that be? Give you a hint. It's a river, right? Rivers on the side of the mountain. What can we call this river?
Sandy River.
Sandy River. Very good. Sandy River. Sandy River carried our sediments from our erosion rock down, and you said it a second ago. Where did those sediments end up?
At the end of the mountain.
And what do we call that?
Deposition.
Deposition. Very good. Deposition. Deposition. That would normally give us like a little lake right here. What could this lake be called?
Sandy Lake.
Sandy Lake, Sandy Mountain, Sandy River. Now we got Sandy Lake. Wonderful. Now I noticed on your model that the deposition, once it starts filling in, what happens?
Begins to create new land.
New land, because those sediment begins to rise on top of each other. What could we call this new land?
Sandy land.
Sandy land. I love it. We got a theme here. Sandy land. Wonderful, wonderful. And I saw this occur on your model. As the sediment chunked off, there was a lot of it that fell down. What is that called when a bunch of sediment begins to fall down?
A landslide.
A landslide, and you had a wonderful example of a landslide. Wonderful. All right, let's stop right here and go ahead and finish up our experiment and see what else happens. Sound good?
Now I have a pretty little rock.
Go ahead and place that into your Ziploc baggie. And let's go ahead and add this new discovery to our drawing.
Okay.
Sounds good. Inside of your, what was this called again?
A sedimentary rock.
A sedimentary rock. We should go ahead and label that so we don't forget. Inside of our sedimentary rock, you found a smooth stone, right? Mm-hmm. We call those a tumbled stone. Why do you think that stone was so smooth, so soft and shiny?
I think it's because of the weathering that was occurring.
The weathering that was occurring, it smoothed the edges, of course. So as the precipitation and the wind and the ice smoothed over your stone, it became a smooth stone. Very good, very good. Let's follow up. Using your vocabulary words, who can describe to me their favorite part about today's activity?
Well, today's activity was amazing on how the model showed me erosion and weathering.
Wonderful, wonderful. And when you were able to see the stone in the center, what had to occur for that to happen?
Erosion.
Erosion. Tell me what that means.
It means the movement of sediments.
Okay, so can you describe to me how you were able to see that smooth stone through erosion?
The movement of sediments had to occur in order for the sediments to move so I could see the stone.
And it exposed the stone
Yes.
underneath. Wonderful, wonderful. Now, here's a question. How long does it take for weathering to happen?
Well, it's happening all the time. It's just sometimes it's slow.
Very slow, very slow. It takes a long, long time for us to see that effect. So this model, what did it do to speed that up?
Well, we did the pipettes,
Mm-hmm.
and it took a little less time to do it.
Wonderful, wonderful, very good. Now that smooth stone, we talked earlier about why it's smooth. Can you using vocabulary describe that to me?
It is smooth because of the weathering that occurred.
The weathering occurs, it kind of breaks down some of the sediment and smooths it out. Now, will that stone ever weather?
It could,
Could,
but it's probably not likely because if it already weathered to the smooth stone, it probably won't weather anymore.
It will weather. It'll just take a very long time, right? Wonderful. Let's go ahead and put our paper and our today's experiment into our journal. Open up to the next page. And we're going to tape in your smooth stone to remind you about today's lesson. And let's just go ahead and fold your erosion paper in half and tape it in on the other side.
Okay.
Wonderful. Erosion Rocks are a fast, fun, hands-on demonstration that provides the opportunity to get your students using the vocabulary words while witnessing erosion and weathering happen in real time. Plus, there's an unforgettable reward at the end. I love Erosion Rocks and I'm confident that you will too. Thank you for watching.